Okay, let's dive into this. We're looking at something really crucial for anyone coding, especially in JavaScript memory management, and specifically memory leaks.
Right. Yeah, JavaScript has that automatic garbage collection. It's meant to handle cleaning up memory you're not using anymore.
It sounds great on paper, this automatic cleanup crew.
It usually is.
Yeah.
But, and this is the tricky part, leaks can still happen. It's usually not the collector failing, but more like our code accidentally holding on to things it should have let go of.
And that leads to problems, right? Slowdowns, crashes.
Exactly. That unused memory just sits there, occupied, potentially dragging performance down or even causing the whole thing to fall over. So our mission here is really to pinpoint these common culprits and figure out how to fix them.
Okay, where should we start? Maybe the simplest one, accidental
Yeah,
globals.
let's start there. It sounds basic, but it catches people out. You're inside a function, you assign a value, but you forget var, let, or const.
Ah, and then JavaScript just makes it global.
In non-strict node, yep, it attaches it right onto the global object. So now that variable, especially if it's holding, say, a big chunk of data, isn't tied to the function anymore. It lives as long as the page does.
So it never gets garbage collected until the whole page closes.
Precisely. The fix is straightforward, thankfully.
Hmm.
Always declare your variables with var, let, or const.
And that ustrict thing helps too.
Definitely. Put ustrict at the top of your files or functions. It turns those accidental global assignments into errors, so you catch them straight away. Much better.
Okay, simple enough. What about manipulating the page itself? The DOM. You can remove something visually, but it can still leak.
Oh, absolutely. That's a huge source of leaks.
Right.
You might use JavaScript to remove a button or a whole section from the page. It's gone visually. But if some part of your JavaScript code still holds a reference to that removed element, or maybe one of its children, the garbage collector can't reclaim that memory. It becomes a detached DOM node.
Detached, meaning it's floating in memory, not on the page, but still held on to.
You got it. And often, the thing holding on to it is an event listener you forgot about.
Ah, right, event listeners. You add one, say, a click handler to a button.
Then later, you remove the button programmatically. But if you didn't explicitly remove that click listener first...
The listener's function still exists, and it remembers the button.
Exactly. The function closure keeps a reference to the DOM element. So the element and anything it references stays stuck in memory. This is super common in single-page apps where UI is constantly changing.
So the fix is always cleaning up, using remove event listener?
Yes. You have to call remove event listener with the same event type and the exact same function reference you used with add event listener. Usually you do this when the element or component is being removed or destroyed. It's a vital cleanup step.
Okay, makes sense. Cleanup is key for DOM stuff. What about timed actions? Set interval, set timeout.
Another classic leak vector. When you schedule a function with a timer, that function, the callback, and anything it needs from its surrounding scope has to be kept in memory.
Until the timer actually runs.
Or until you cancel it. If you set a set interval to repeat something, maybe update a clock every second, and you never call clear interval when that clock component is removed, that interval function and any variables that closed over will just keep living in memory forever, or at least until the page closes.
Right, so always clear interval or clear timeout when you're done with them?
Absolutely critical, especially for intervals that might hold on to significant data.
Okay, one more big one. Closures. They're powerful, but can they cause leaks too?
They can, indirectly. Closures are functions remembering their creation environment, right?
Yeah.
Accessing variables from their outer scope.
Yeah, that's what makes them so useful.
It is. But imagine an inner function, a closure, that holds a reference to a really large variable or object from its outer function. Now, if that inner function somehow stays alive for a long time...
Like assigned to a global or used as a callback for a timer that never gets cleared.
Exactly. Then the closure keeps that large object alive in memory, even if nothing else needs the object anymore. The closure's reference prevents garbage collection.
So you need to be careful about what closures are holding on to, especially if they live for a while.
Precisely. Be mindful. Sometimes, if you know a variable within that scope is no longer needed, explicitly setting it to null can help break the reference chain.
This feels like a lot to keep track of manually in a big application. How do you actually find these leaks?
Good question. The browser developer tools are essential here. Chrome, Firefox, they all have a memory tab.
Ah, the heap snapshots?
Yep. You take a snapshot of the memory heap, perform some actions in your app, take another snapshot, and then compare them. You can see which objects are growing in number or size unexpectedly.
And you can look for those detached DOM nodes we talked about.
Exactly. The tools highlight them. You can also record allocation timelines to see which functions are allocating memory that isn't getting cleaned up. Learning to use these memory tools effectively is, well, it's a really important skill.
So wrapping this up, understanding these common leak patterns, globals, detached DOM, listeners, timers, closures, it's not just about fixing immediate bugs.
No, it's more fundamental. It's about writing code that's robust and efficient over the long haul, ensuring your application stays performant and stable, even as it gets more complex or runs for longer periods.
It helps you build better software, basically.
Definitely. It takes the guesswork out of performance problems.
Okay, here's something to leave everyone thinking about. Given that JavaScript does have this automatic garbage collection, why is actively managing memory references and thinking about preventing leaks still such a core skill for becoming a really proficient, expert-level developer?